We're all the way in 11.2 for arithmetic sequences and series. And we're primarily focused on the sequence part. So if you've ever been given like a list of numbers before, like say 3, 5, 7, 9, right? Like we know those are like multiples of odd numbers, right? Or just like odd, yeah, they're all odd numbers. But how do we get from 3 to 5, 5 to 7, 7 to 9? Well, we're adding 2. And so that pattern is an arithmetic sequence. And so we're going to be figuring out, okay, if I give you a list of 3 or 4 numbers, what's the 10th number in the list? And so we're going to be looking at a formula to find it, as well as just like actually, we can count it out, obviously. But a formula makes it easier because one of the questions in pre-cal the other day was list the 8th term, then list the 100th term. And quite frankly, you probably don't want to keep adding 2 until you get to the 100th term, right? We would want to have something that makes it easier. And so, anyways, we're going to be looking at that. But an arithmetic sequence A sub n is an arithmetic sequence if it can be written in the form A plus D, A plus 2D, so on and so forth, A plus n minus 1 times D, ... and again, so on and so forth. So this is kind of just the general form. So this would be like, okay, 3 plus 2, 3 plus 2 times 2. So that would give us, 3, 5, 7, and so on and so forth. As we would keep going, and this is for some constant D, which is just what are we adding to everything to get to that point. The number D is called the common difference. So your book is nice because they teach arithmetic sequences separate from geometric sequences. And the reason that I say that's nice is because a lot of books combine them into one, and you're having to sit there and distinguish which one's which when you're just learning the material. And so this is nice because you'll know in this section we're only dealing with arithmetic sequences, and we only have a common difference because geometric calls its common thing a common ratio instead. And we can obtain each term in an arithmetic sequence recursively from its preceding term by adding D. So we would have A sub n is equal to A sub n minus 1 plus D for all n greater than or equal to 2. So this one basically requires that we know the previous term and that we add it to, or we add the common difference to that. There is another form of this equation. I want to make sure I write it correctly. So let me look here. Have it in my notes. Get to the right class. Maybe. The other form of this that is to where we don't have to know the previous term, we just have to know one of the terms, is if we write it as a sub n is equal to a sub k, and that can be any term that we know. Doesn't have to be the first one, doesn't have to be the previous one. Using the first one makes it the easiest, but doesn't have to be that. Plus n minus k times d. So if we're using the first term, that's nice and easy. If we're using a different term, that's when we're going to be subtracting stuff off. But basically that's saying, like, if I want the 8th term and I know the first term, then I can do, okay, whatever a sub k is, whatever that first term was, plus 8 minus 1 times whatever my common difference is. So in the earlier one I was saying where it was 2, then I would plug that in and I can find the 8th term by just using this formula. So if I know the previous terms, I can use this one in blue. If I don't know all the previous terms, like I have to know the one right before it to be able to use it, but I know the first, second, third, whatever term, I can use this last one. So this one will always work, okay? If you want the 100th term, I would not recommend using this one. I would use this one in red, okay? And obviously as we do examples, it will make more sense as well. Trying to see here. So, have you ever heard of the Fibonacci sequence? Okay. So, it doesn't look like our book directly talks about it. It's not like something you have to know, but it's kind of a cool thing to know. But the Fibonacci sequence, it's found a little bit differently, but it can be defined recursively by a sub 1 is equal to 1, a sub 2 is equal to 1, a sub 3 is equal to a sub 1 plus a sub 2, and that would equal 2 in this case because 1 plus 1 equals 2. And then we could keep going down. A sub n is equal to a sub n minus 2 plus a sub n minus 1. And that is for all positive integers n greater than or equal to 3. So all this is telling me is I take the two previous numbers and I add them together to get the next one. So that's what this generic form is here. So if I wanted to find a sub 4, I would add a sub 3 and a sub 2 together. The fourth term is 3. Then I would do 3 plus 2. That's 5. 3 plus 5 is 8. And so on and so forth. And I could keep finding these numbers by adding the previous two terms together. So, jumping into some examples here. They just want us first to determine the common difference D for each arithmetic sequence. So, I'm going to also say, like I kept saying, like we're basically adding a number. We can also be more or less subtracting a number, adding a negative, however you want to think about it. That's another option. And so, just be aware that sometimes we may be subtracting something, but it works the same way. So number 12, they just want us to state the common difference. And so this one, they give us 4, 10, 16, 22, ... So what am I doing to get from 4 to 10, 10 to 16, 16 to 22? Yep, adding 6. So D is equal to 6. D is always our common difference. -14, -8, -12, -16, -20, and so on and so forth. How am I getting from one term to the next on this one? So notice they're negative numbers. Yep, -4, so the common difference is going to be -4 on this one. So that means I'm subtracting 4 to get from one term to the next. Let's see. Find the first 5 terms of each arithmetic sequence. So depending on how they give it to us, we'll determine how we do this. So 18, they give it to us in words. The first term is -2, and the common difference is 12. So that means that I know that the first term is -2. I'm finding the first 5 terms. A lot of times, I mean, not so much with this one, but when I get finding a lot of terms, I'll actually sit here and I'll put blanks for like, okay, I need to find, I have the first term, I need the next 4 so that I know that I get them all. Again, you don't have to do the blanks. I just find myself doing that sometimes to make things easier. So the first term is -2, and the common difference is 12. That means I'm adding 12 to that first number. And so -2 plus 12 would be +10. 10 plus 12 would be 22. 22 plus 12 would be 34. 34 plus 12 would be 46. And that would be the first 5 terms. Obviously, I could keep going if I wanted to. But that's all they want. Let's see, 20. They give us A sub 1 is equal to 4 and D is equal to 3. So they're telling us the same information that they gave us in 18. It's just not written in words. So A sub 1 is 4. That means that's my first term. D equals 3, that means that's the common difference. So I've got 4, and I'm finding the next 4 terms, because I'm finding the first 5 total. So what would the next term be? And then next. Yep. And last one. 16. Yep. So nice and easy, we're just adding that on. The next one, say to determine A sub n and A sub 8 for each arithmetic sequence. So 24. So basically what I'm going to do is I'm going to write a rule, probably using the option that I had written in red, A sub n is equal to A sub k plus n minus k times d, to do this because it wants me to find the 8th term. And based on some of what they've given me in some of the later problems, this is probably going to be the easiest way to do it because they're not always giving me the first term. So, let's see, 24, they give us -3, -7, -11, and we are finding a sub n, and we're finding a sub 8. So how are they getting from one term to the next? What's my common difference?
-4.
Yep, they're subtracting 4 off. So now I need to write like a general rule for a sub n. So using that formula, a sub n is equal to a sub k, where'd it go? A sub k plus n minus k times d. Let me write that down here. Just so we have it handy and I don't have to keep scrolling back. So a sub k can be whatever term we want that to be. So if I want it to be the first term, then I can put that as the first term. I can use whatever term, but I just have to remember which term I'm using. I'm going to start with -3. So this is going to be -3 plus, in parentheses, n minus, well, this was the first term, so that means k is the first term, so that means it's 1, times -4. Now, because this was negative, that's why I'm putting it in parentheses. You can also put that number in front if you want of the n minus 1, however we want to do it. It's the common difference for how we get from one term to the next. So when I find the 8th term, I can either use this formula or I can use, I can just subtract 4 off, okay? So if I were to just keep subtracting 4 and keep writing numbers down and do it that way, then I would end up with, if I subtract 4, -15, -19, -23, what's that, 1, 2, 3, 4, 5, 6, -27, and -31, I think. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. And so this would be the 8th term. But I can also use this formula that I wrote to find the 8th term. Okay, and so that would be -3 plus this number here goes for n, so 8 minus 1 times -4. And so this would be -3 plus 7 times -4. Well, -28 plus -3 is -31. And so you'll notice those are the same. So using the formula, I get the same thing as if I work it out by hand. Again, just going to like the 8th term, 10th term with arithmetic, it's not that bad. If we wanted a 100th term, that would be a pain to write out every time. So using the formula would make our life a lot easier. Now, I'm probably not going to ask you for the 100th term, but to ensure that we know how to use the formula, I may ask you to find like the 20th term or something like that. Again, not unreasonable that you couldn't do it by hand without using the formula, but the formula would make it easier. Let's see. 28. A sub 15 is equal to 8, and A sub 16 is equal to 5. So obviously, I don't have a first term given to me, but I do have 2 back-to-back terms. So how am I getting from 8 to 5? Yep, so that means D is equal to -3. So I'm finding, again, A sub n, and I'm going all the way back and finding A sub 8. That means I'm working backwards. Now, if I'm working backward, that means I have to add 3, right? So I just have to be mindful of that, which that's where the formula will be really nice because the formula is going to cause that to happen when we write it. So a sub n is equal to a sub k. So we can choose either of these, really doesn't matter. I'm just going to go with a sub 15, so that means 8. Plus n minus, this is the 15th term. So k is 15. Times the common difference of negative 3. And if I want to test and make sure that I did this right, I can plug in 16 here. So 16 minus 15 is 1. 1 times negative 3 is negative 3. Plus 8 is 5. So I know my formula is good, right? So now I want the 8th term. That means n is equal to 8. So I would do 8 plus parentheses 8 minus 15 times negative 3. Well, this causes us to get a negative in here, so that's negative 7 times negative 3, all that plus 8. So that's 8 plus 21, or 29. So that means that the 8th term was 29. Now, I could get that by adding 3, right, until I get all the way back to the 8th term. But if you're going to do that, I would definitely write out blanks so that you make sure, that you get to the right thing. Any questions about these? You feel okay? I don't think they're anything like super hard and crazy, but it's just different than what you've typically done before. So problems, just a few here. 11, 13, 17, 19, and then let's go 25 and 27. So just 6 problems here. And then probably tomorrow, I'm trying to think of all the days, what's going on. Probably tomorrow we'll do geometric with this as well. So